We will have on stage Răzvan Ionescu, who will teach us how to mess with Android Intents.
Okay. So, hello everyone. I hope you are at the desired presentation because it was a little bit something happening in the schedule. So thank you everyone for coming. Today I'm going to present you an open source project. We have developed this open source project for about 3 or 4 months, so it's pretty young. And the message of the whole presentation is please come up with some opinions on how to see it, how can it be improved actually. So we are requesting some feedback from you. We are asking you to provide us some feedback. Any ideas how can this project will be improved? Okay. It worked. Now, so my presentation is called How to Mess with Android Intents. I am Răzvan Ionescu, and together with Cristina Ștefania Popescu, we have developed this tool. Android Intents are one of the important ways how components inside Android communicate. So this is a part of inter-process communication actually in Android. Here we are. So yeah, once again, this is me. Here are some of my passions. I'm a geocacher, tracker, squash player, and Ștefania in her own words. Now, today's agenda, I will focus on 3 main points. Our motivation, some existing solutions which we have researched before, so to say, and our module, our project. First, our motivation. Well, how many of you are using an Android phone? A lot. And for how many of you, security is important? Thanks. So that's why we have come with this open source project. We wanted to address one issue. Not all the times Android intents are sanitized. And a way how to test this is to stress them or to fuzz them. And this way you can check if Android components, actually Android applications, can handle malformed intents, malformed messages, so to say. A little bit of research we have done before we start our project. It's a paper called Intent Fuzzer Crafting Intents of Death. They have found some crashes in native code for top apps like Facebook, WhatsApp, PayPal, I think. And this was one of the sources of our project, so to say. I mean, we got some ideas from them. Then another project is this Droid Fuzzer, fuzzing the Android apps with intent filter tag. This is a research paper written by some students, some PhD students, somewhere in China, if I'm not wrong. And unfortunately, their project is not public. It's closed source. I have tried to obtain the source code, but they said that they don't collaborate with us. So we were on our own, so to say. Another project is this intent fuzzing project. Some guy called Thomas has tried to develop a module for Drowser. Drowser, for those who don't know, it's a framework for assessing security vulnerabilities in Android. We are going to discuss about it a little bit later. And the constraints of this primitive module were that they were interested only in broadcast intents, and basically they have just hard-coded things there, and they didn't do too much fuzzing. They just send broadcast intents within Android applications. This is how the architecture of this module looks like, and it looks a little bit complicated. And now we have come with our solution to make something very simple, easy to use, and easy to integrate with browser. Those are pretty much the steps when we are discussing about intent fuzzing. So we extract some information from our app. We generate intents, we fuzz them, and we send them back to the application. We execute those intents. This is how the browser looks like, the interface. Basically, you have a client on the device under test and the server on your Linux machine. Browser communicates through a port. By default, it's 31415. That's why you have to forward first the TCP port to this value, and then you can communicate with browser. These are the commands in order to use a specific module. So if you are developing your own module for browser, just put it on a path and then issue that command, module repository enable, and then you will have your own browser module inside browser. This is how the main class looks like for our project. Here are some options you may pass to our intents fuzzy noser module. We can, you have to pass the package name you want to test. You may choose to test all the packages inside the device. You may send either broadcast intents or fuzzing intents. Basically, those intents have like 6 parameters, and you can choose between fuzzing specific parameters or all of them. Of course, if you want to fuzz a lot of intents on for an application, maybe some crash may occur, and it's very good to use this option, save state, just not to be put in the situation that you have to rerun the whole session again. By saving the state, then you can reload it exactly from it remained. Of course, you have to specify the device. If you are testing on multiple devices, you specify the device ID. And we have also performed the denial of service attack against the activity manager by running this, our module. This is how the architecture looks like. Here you have the device under test running the browser client, and our module is collecting first informations, and then you can you can trigger actually any option you want. And in the end, you will obtain some logs, some seed files. Those seed files are very useful if you want to see which track, which trace led to a crash. And if you want to make the device to be in the same state as it was before crashing. Those are the whole options and their dependencies. If you have a seed file, you can run the same seed file again to retest if the application has been fixed, for example. So you find the bug, then you patch it, and then you rerun the seed file just to see if the patch was actually fixing your problem or not. Those are some examples of how can you run this module. You can do it also outside browser, simply by issuing browser console connect -c and then the command. This is very good because maybe you want to automate things. You don't want to be inside browser and type so many commands. You can do a script and you can trigger these commands actually outside browser client. This is how you run a seed file. This is how you run a complete test with reload state. So we have 5 parameters which we save. And for example, if you want to reload from this state, you simply pass those values to this parameter. Regarding our results, we were able to find a lot of Java null pointer exceptions, illegal state, class not found, security exceptions, and so on. And as I said before, we have performed a denial of service attack against the activity manager. Actually, exactly during the denial of service attack, any app you want to try to open, it will shut down automatically. This is our GitHub project. We were uploading our projects right here. This is our QR code, which leads you to this GitHub, so don't be afraid to scan it. Maybe Georgia told you yesterday that it might be dangerous. No, this is not. We are going to upload also this project and make it open source on 01.org, which is the Intel GitHub. So you can see all the open source projects Intel developers have published to the community. I have also a small record of our denial of service attack. This is how does an a fuzz intent looks like. For example, here we have the extra value parameter fuzzed. And here we have the data URI fuzzed as parameters. And of course, we can reload, as I said before, from any state we want. So if any crash occurred in the meantime, we can save the state and reload from that state further on. Now, I'm going to show you how did the denial of service attack look like. It was performed. Of course, it was performed. It was performed on a Nexus device, Nexus tablet. I have updated it like 2 days ago, so it has Marshmallow. And it takes only 3 minutes, so don't worry. So we have here the device. I have used this visor because you can see the device in the same time with your screen. So it's a Chrome plugin actually. Sorry. You can also interact with the device screen. Okay, now I start the browser client. I'm enabling the server to listen on port 31415. For this matter, I have to forward first the TCP port for ADB to communicate with my client. And this is how the console looks like. You can type commands like ls, help, run, and so on. This is the whole list of modules you have by default. And here is our module installed inside browser. I'm going to use app package list to list all the modules, and I will filter by Bluetooth. I'm just choosing this package for my denial of service attack. it's pretty important not to have an activity which pops up if you want to succeed. By issuing help, you can see the whole options you can use for any module. And for demo purposes, I will use the denial of service attack option. So I pass the name of the module, package name, Android Bluetooth, and then the denial of service attack, and you pass actually how many intents do you want to be sent to the device in order for this denial of service attack. And this is what happens on the screen of the device. It's a real device, not an emulator. So if you try to open any app, it will shut down. Some of them are shutting down very quickly. Some of them are thinking a little bit. Yes. So this was pretty much my presentation. I want to thank my open source security team for supporting me, for supporting us. And if you have any questions, I'm here to happily answer them.